Okay, good morning, everyone. I think we'll get started, so we're a little late. So I one more time offer to you, right? If I'm here 30 minutes before and after this morning was 20 minutes before, but and if everybody leaves later on after the class, then I don't have to stay, right? So I'm not going to stay if nobody is here. Today, what we will do is we will start building. So we'll start building a product, a prototype. A minimal viable prototype, or at least we will get the baselines done for it. So it's a lot of individual work today, so quiet work. You have to paint and you have to actually go around and see what you have written down and you create a story. And that's what we'll do probably in the early afternoon. And I'm just going to give a little forward look for tomorrow. So for tomorrow, we will do a little bit of lecture in the morning. And then in the afternoon, it's basically for you to put everything together, to work on your prototype or promotype. I'll give you some examples today too of what that could look like. And you will probably, you should have a laptop with you or a computer to put everything together. You should have a presentation prepared, right? And I would strongly advise you, because you are in teams, and teams have certain strengths and certain weaknesses. I don't know if you have already seen that in your group. Sometimes you have a group and then there is 5 people and one person is the only one who's working, or 2, and the other ones are kind of like sitting and observing. That's typical, not unusual, and it's in India the same than in Germany. You have always some people who are more excited about it or more into it, and some others are not. But as a team leader, and today, actually so far we have already we have always said there is a decider, right, in your group, and this decider really didn't have to decide very much yet. But today will be the time when the decider has to decide something. And the decider should also be the one who kind of looks a little bit after that it gets done, okay? And maybe also distribute the work a little bit, because otherwise teams are not more efficient than single people. So teams have, the really good thing about teams is that you get a lot of different opinions in. And that normally makes a product or makes an idea better. So I can only encourage you in your team to raise your voice, to raise an opinion, and to say what you think. Because if you don't say, nothing will happen. It's the same thing with this, right? If you don't work on your own future, the future will be determined by somebody else. So if you don't involve yourself and you don't try to get hurt, nothing will change. Now, it doesn't mean that when you're hurt, things will get changed, but you at least tried, right? And you can be convinced. You shouldn't be totally stubborn on things. On the other hand, if you really believe in something, you should be stubborn. Then you should really push for it. Okay? So you already know the procedure, day 4. Procedure is sit together first, try to exchange your ideas, and put it together. I'll give you about 5, 6, 7 minutes for that. And so this would be the summary for day 3. We will do one for day 4 as well tomorrow. And then for the last day, we probably won't do one. Or you can do one, but I'm not going to tell you one more time, okay? All right, get started. This is the first job. 5 minutes. You know how to do it, right? So, done one thing. Get to the next thing to do. I ask you to do a little pain gain analysis. Just a pain gain analysis. So, what you should do is, how many of you think they have more than one customer? Everyone? How many think they have more than 2 customers? Also pretty much everything. Do you already have a firm understanding of who your customer is, who your most important customer is? So I would advise you to do actually 2 pain gain analysis for the 2 most important customers. If we do too many, then it takes too long. But pick the ones, that's the first decision you have to make, pick the ones that you believe are the most important customers, and then do 2 pain gain analysis. I would advise you to use the sticky notes, maybe make a chart, And then everybody puts down what they believe in quietness, what they believe are the most important pains and gains that you can solve. Do you remember one more time what a pain and a gain is? A pain is something that actually is hurting that person. It's kind of like a problem for that person, for that customer. A gain is something where it could benefit. So it's not like you give them something. What is empathize? Put yourself into the position of that customer. So I would advise, again, to come up with a sheet, and you put down pain gain for customer A, pain gain for customer B, and then everybody of you writes on the sticky notes the ones that you believe are important. And then once you're done with that, everybody, you start voting on them again. Okay? All right? I'll give you about 10 minutes for this, okay? And you need papers, they are in the back. I'll give you some. One. I'll give you some more, right? That's quite a bit, right? You just collect them for the future. Now you're very welcome to take things down from your wall that you believe are not that important anymore. Maybe the drawings that we did all the way at the beginning, or you put it on the floor. But you need to be able to see it, whatever you think is relevant for your product. Do you have enough sticky notes too? Okay. Do you guys have enough sticky notes? Yeah, I'll get you some more anyway. So that people write their own little notes, right? So I don't want to interrupt discussions, but at the end of the day, it's good if everybody has his own ideas put forward, and we should try to get to an end. So maybe another 3-4 minutes. I'll show you a paper or a video later on how it's normally been done. 3 minutes, time. Can you get moving on here, please? Let's get it done. Yeah, come on. Then they start voting on it, please. You know, hang it up somewhere. I would advise you. I don't know. That's up to you. You want to put the things down you don't think you believe anymore, or you put these ones aside and then put this one up. See, these ones I like a little bit. So 4, 5, 6, those are really good. So just use 4 or 5 votes. You just make it up yourself how many votes you want to use. Can you help her, please? She's by herself. She's doing everything alone. Come on. So has everybody voted on it? Okay. Come on, let's get to a finish, please. We're already at like 25 minutes for this exercise. Okay, so I think we're getting to an end here. The group in the back is a little slow, I think, or both groups in the back. Those are the largest groups, right? So the C size is not always good. Okay, so while they're finishing up in the back, I'll do what I do every day so far. I give you a little bit of review from my point of view. So we started off doing this future game. I thought you had some fun doing this because I think it's a very powerful, very short game. And you should try to play this every once in a while just when you want to find out what certain effects are. So you start off with basically putting a topic in the middle, and then you actually do a very short round and try to come up with indications or implications of this technology, and then do a second order implication, and then maybe you decide or discuss what came out of it. We talked about ethics, and please remember this bottom sentence, because I think that's really important. It just should make you aware of the fact that there is maybe a difference between what you have a right to do and what is right to do. And that is dependent on your own. That's the problem with the whole ethics part. But I would not do things that are against my own beliefs. So if somebody tells me I should do that and I believe it's not right to do it, I wouldn't do it. So up to you, but and also you remember what dual nature was? So the yin, the yang, the good, the evil. So there's always two sides of the coin. I mean, there's a lot of sayings in a lot of different languages. There in Germany, would say that there's two sides of the coin. And so there's always one bad and one good one. But we are sometimes very, very much into just believing in the good one, because that's the one we want to do. And that's our goal, is to do something good. And then we completely forget about all the other things. We just don't even think about it. Then we talked about lean, agile, scrum, sprint. Scrum, well, let's start over on the right side. Lean is approximately what agile means, approximately. There's some slight difference, but they're not important for this class. It basically means that you do things agile, not like, oh, slow and sleepy, agile. And you go about and check on whether there's a market or there's a need for what I'm proposing. And agile also means I'm trying to get things done, the proving point done relatively quickly. I try to find out what the value propositions are, the main ones. And then I try to build a minimal viable product. And if I find out that's completely a dumb idea what I came up with, I just fold it, throw it away, and do something else, start again. Fast motion, fast checkup, it decreases the amount of uncertainty. You remember the curve again? Decrease of uncertainty. So with more time, more uncertainty, but you can actually do it also a little faster by checking not only the path that leads to destination, by eliminating the ones that do not lead to the destination. So, and then to be agile, there's different types of development technologies you can use. One of them is Scrum, where you basically, as a development team, pick your own topic. It's a topic by itself, Scrum. But if you would get into software development, you will find out that Scrum is a fairly often used technique, and is a very powerful. Sorry. So it's a very powerful one as well. But Scrum by itself would probably take about 3 or 4 days to teach you in the basic level. So not needed. You just need to know there is ways to do that, and you can look it up. And then there's also something called, every day we have someone, right? So it's over there. So go stand up. Shame on you. So there's design sprints, and we will do design sprints this afternoon. And a design sprint normally is a 5-day process, very complicated process, but we'll try to reduce it today and limit it to kind of like the building, no more the identification and building process. We have started already quite a bit. I would advise you later on, before I go on with the review, after the coffee break, please rearrange your information. So I would advise you to just throw away everything you don't think you need anymore. So maybe all the stuff that is not related to your project itself. You can keep it, make a picture of it, but eliminate, take it off the wall because you need some space. And put the things on that you believe are relevant for your project idea. Okay, so I would really advise you to do this and do that in a team. Because while you do it, you can still read over it a little bit. So we will actually do later on an exercise or part of the design sprint where everybody goes through their notes again in quietness, try to understand what that proposer of the project has told them, basically also look at the pain gains of the customers that are involved, and kind of like try to come up with a story for themselves. What is so important? What is so good about this project? What are the main problem areas? So I want everybody to be prepared to do this. You're not supposed to write an essay or a thesis, but maybe bullet points. So it really gets everything back into your head. Okay? So just be prepared that you have to do this. So in general, these technologies now are the 21st one technologies where you're not going for things that you know for sure will happen, like a car being improved, right? We talked about these incremental innovations. This is a typical thing for waterfall development. You have a market, you know what it looks like, you know what your customer want, and you basically just work on product performance innovation. Then you don't need this type of of approaches. You need these approaches when your market is uncertain, your customer is uncertain, you really don't exactly know what they want, don't exactly know what you would do to get them to buy something. This is for uncertainties. Now, everything you do in a startup company is pretty uncertain. Or everything you do on a new project which is disruptive is completely uncertain. So those are the things that I believe are very important for you to know. Also, when you want to check something in the healthcare domain or on the medical imaging, image-guided therapy domain, you need to check uncertainties with your customer because you are not the customer yourself most of the time. Okay? So in essence, it's not enough thinking is put into the what to build, why, for who, and how in general. And we try to avoid this. So you've heard it many times, probably also a question on the test, so who's not here, they will not know that. What is it? What do we do? A painkiller for a burning problem. You got it. So what we're trying to do here is we're trying to find a burning problem first, try to understand the customer and the market first, and then try to see on whether we can find a painkiller. Or you can also have a painkiller, but then you need to really find the burning problem for it. And it's not often the one that people anticipate it will be. Okay, this is just a different development process. As you see, the waterfall is basically you start at some point in time, you finish at some point in time, and the product is finished, done. And the ones with the agile and lean, you do actually incremental products. You add things, but they're always run by itself. They're always usable by itself. It's basically a software release on the iPhone or the Android. Comes every month. And then there's a major one coming every year. Okay? And then this is the typical healthcare design thinking process that's also used by the Stanford Biodesign program. So the first and foremost important thing that you need to get done or you need to understand is the empathy. Empathy, and that's what we just did with the pain gain, is to understand what the customer does. What kind of benefits it could have. I hope it comes later on, but it's also one of the maybe jobs you should do at some point in time is to build this empathy map. Remember the empathy map? What you're thinking, what you're talking, what you're doing may be completely different things. So an empathy map is very important. So you start with the empathy, which means in our case, imaging, we need to understand how the radiologist works. We need to understand how the interventional radiologist works. We need to understand how the image-guided therapist works. How do you do this? By watching videos? Yeah, it's a good starting point. YouTube videos, or you start how a surgery is done. But even better, to go there and watch it. So part of I believe my best lecture and the one I like doing the most is when I send the students to the surgery rooms. So they have to completely get their dress on, their surgical dress. They stand in the back, make pictures or notes, and they actually watch how things are being done. Now, where would you normally look when you go to a surgery? You look on the table, don't you, where the patient lays? You know what? Tons of innovation is around the table. And that's what actually a lot of people don't look at either. They always look at where the action is, but they forget that to get to the action, there's a lot of things that happen before. Getting the patient on the table, getting the patient prepared, monitoring the patient, kind of like looking at the actions around it. I believe there's a significant more amount of innovation in the vicinity, in the surrounding of the surgical table than on the surgical table itself. Because the surgical table itself is the one that everybody looks to. You remember I also gave you an advice to look at things where when it's done for a long time and people seem to be happy, well, still a good reason to look at it anyway, because then maybe people just have accepted the current status quo and have not looked at it anymore. So please also, when you look at these type of innovation, look in the surroundings. And you would be surprised when you go to these surgical rooms what you as an engineer can contribute. I'll just give you a quick example. I went with my group. We went to one of the foremost top surgeons in the world, and he allowed us to come in. And it's very interesting because I told him the reason why we would want to come in is because we want to improve your surgery. And what do you think the guy said? He Because he was laughing, right? He said, yeah, I'm the best in the world, right? Or one of the best, what can you improve in my surgery? But he was interested enough to try it out. And what we came up with is about 10 little ideas. Or maybe even more, I don't remember how many more. The first one was that, he walks in with his gloves, right? Walks in like this and walks straight onto the surgery room, or surgery table. He doesn't look left or right. So the engineers, of course, I told them should look left and right. And they saw cables laying around there, cables laying there. People could fall over it, right? And so we mentioned these couple of things to him. And I went back 3 weeks later, all gone. All cleaned up. They don't look at this anymore. And the good surgeons will allow you to come in because they know they can get better by having other people look at it. And you guys are completely naive with respect to surgery. That's good. It's not necessarily bad because you ask questions that people would normally not ask. You say, why is he doing this way? There's other ways to do it. Now you maybe find out that the other way is not the better way, but at least you ask the question. So that's the way to actually go about. You need to empathize. When you have actually identified problem areas, you said, oh, this is we should look more carefully at this one or this one or this one. You define the problems. And when you have defined the problems, you actually try to find a solution. You ideate. You come up with a solution. How do we solve this? And typically, when you have 5 people, you come up with like 5 or 10 ideas each, 50 ideas. And if you really cluster them, you find out that many of you have the same ideas or same area of ideas. You cluster them, and you're trying to find a common denominator, common idea description. And when you have done that, that's why you have these arrows. You go back and forth. You may actually say, did I really understand this right? Let me just check again. You go back to the surgery and just say, You don't necessarily have to ask people, just observe. And when you find that this is all a good idea that you have, you may want to build a prototype. And today, this world is getting so much easier building prototypes. In my lab, we have 5 or 6 3D printers. We just make a CAD file, and we print it. It goes really quick. And it's really inexpensive, and it sometimes serves a purpose. You not necessarily put it on a patient, but you give the medical doctor something in the hand. I said, this is not our idea. Look how it looks. Can you imagine? And then they can imagine it. Just talking to them is very difficult because they have other things on their mind. Showing them something is a very powerful tool. Now, when you find out all this stuff works, you may want to implement. And then maybe make a real product out of it. And then think about regulations, what we discussed yesterday as well. But I would not think about regulation before I'm at this point of having built a prototype and maybe decided to go further. Okay, empathy map, so we still have that. So think about this empathy map. That's a very, very powerful tool. It's as far as I'm concerned, the only tool which allows you to really try at least to understand your customer. Then we talked a little bit about Blue Ocean strategy. And Blue Ocean strategy is a very powerful tool for disruptive evaluation. Disruptive. So doing things completely different than they were done before. And by what you do here is you actually try to analyze what is the highest value, the most important value proposition that your product and or your customer have in common. And you try to raise that, because that's the reason for the customer to purchase. It's that must-have. And that I cannot live without it, have. Going back to the car, you need to have something where you sit in, go from A to B, and whether you have an air conditioner is a nice to have. But you're not buying it because of the air conditioner. The air conditioner is something where when you have 2 or 3 products in the same area, then you say, well, one has an air conditioner, so I'll buy that one. But if you don't have 2 or 3, then they will decide for this one product feature. Blue Ocean means you try to go into a market that is uncontested. There's no competition. You don't have these 3, you only have 1. You try to actually find a market where you are somewhat alone. And you can only do that by actually focusing on that one extremely important value proposition. So, very powerful tool. It is relatively easy to implement. If you would do a class on it, it would also take another week. But the important feature here is that you make a careful analysis of your pain gains, a careful analysis of your product. You try to come up with the highest value proposition. You want to make that more powerful, and you want to make that cheaper. And that creates something called value innovation. You can also use this in combination with the value proposition canvas. Value proposition canvas, you try to prioritize jobs to be done, prioritize pains and gains, and you actually then try to come up with which could be the highest value to a customer. And where can you do the most effective innovation, value innovation? Then the next thing we talked about was innovation segments. How many of you did think there was more than that innovation was subdivided in like lots of different things? Not a lot of you, right? Interesting, then you look at that, it makes sense, doesn't it? That there is all kinds of different types of innovation which address a different part. They address maybe your brand recognition. You know, people rather buy an Apple product than a Huawei product if they would be at the same price, right? Brand is an important thing. They would also see that actually coming up with an economic innovation, a new profit model, renting cars on a street out there rather than selling cars could be a completely new profit model. Or the scooters that are everywhere now these days, not in India probably, but if you go to, I just came from Australia. Go to Australia, everybody rides these e-scooters around. You just park them, you lock them with your cell phone, and when you see one, you unlock it and you take it. And you are paid for by kilometers or minutes used, I don't know. So, really cool setup. Completely different business model. And then it's for you, it's like iTunes, remember? 99 cents per song rather than $9.99 per CD. You just pick whatever you need. You don't want to have the whole CD, you only want to have 2 songs out of it. You don't want to have an electro scooter, you only want to use it 3 minutes a day, or 5 or 10. Why would I buy a scooter for $2,500 if I can rent it for minutes on a, I don't know, cent basis? So we looked at this. We also looked at device regulation, and basically device regulation is dependent on the risk that is associated with the use of it or with the information that comes out of the system. So if you implant a heart pacemaker, is the risk high or low? It's high, right? It's an invasive device, it stays in for a long time, so it's quite risky, right? And if there could be biocompatibility issues, the body doesn't like the pacemaker, there's a high voltage, there's a lead, right, going to the heart. It doesn't sound quite dangerous. The same thing goes for anything that is implanted in your body, that stays in your body for a long time. Everything where you use a temporary access, you just cut open, is not as risky because it's only a short-term use, but it still is in the middle range. And then you have the ones that either provide diagnostic information that are also in the middle range, or that are completely safe because they're just placed on the skin, bandages, inhaler tubes. Well, inhaler is actually probably a 2A device. It's probably more in the middle range because you actually get into the respiratory system. But all these devices have a different risk associated. So if you develop something ever, you want to clearly understand what every part of what you're doing, what kind of risk that could inflict onto the system, and with that to the patient. So document everything, come up with like solutions and strategies of how to prevent this from happening. There is this chart here which kind of like shows them whether things are acceptable or not acceptable. It's called the ALARP principle, as low as reasonable possible. And there's acceptable, non-acceptable risks, and something in between. That's what the Americans use. The CE is the European label. We don't have that in the middle. We basically have it very digital, 0. So 1 acceptable, 0 not acceptable. Nothing in between. Please remember, and I think that's important, frequent occurrence is already 1 in 1,000. More than 1 in 1,000 is already considered frequent. So that's quite a hurdle you have to jump over. Okay. So that was a review from yesterday. Did you miss anything? Did you come up with the same thing or other things? I hope you came up with other things, because I want you to come up with other things, the things that are important to you, rather than the ones that I believe are a summary. Okay, I want to talk to you just in short. So we have a coffee break again at like 11:30? Okay, so I don't know exactly what comes after that, but so I want to talk with you quickly about intellectual property. Also, just like like yesterday when we talked about regulatory, it should not be of your prime concern, intellectual property, but it should be something you should think of when you are at this, let me put it this way, at this phase before you implement something, right? This design thinking phase. Maybe at the phase where you build a prototype and you believe it's a really good prototype, it will work, then you have to think about IP. Now, anybody have an idea what IP is? What does IP mean? Intellectual property, sorry, stupid me. But what is included in that? What does it mean?
Something which is novel.
Yeah, but what does it mean? What is it? What is this? What is it? A patent, for example, right? A patent is intellectual property. What else is there as intellectual property? Yeah, but that's how do you protect it? In a patent, maybe, right? Anything else you can patent? Huh? What else is IP? How about software code? Copyright. A brand. Apple, right? What else do we have? Trademarks, yeah. Like things you wrote up. What was it? Taglines? I don't know what that is.
Like just do it for 90 years.
Oh, that's a brand, or that's a trademark in a way. You can brand that. So there's a lot of things, and it's not only the patent. So here's a little bit of what the IP rule looks like. There's a lot of things involved. Registered trademark, common law, copyright, design rights. Design rights, for example, is an architect has a design right. So when there's a competition and architects actually put in their drawings, they have a right. That's their design. Now, even if you actually you have a contract on the architect and said, well, that's kind of cool. Yeah, I'll take the design and I'll build it, and you change it, for example, the architect can sue you because it's based on his design. So there's a lot of interesting things going on. Ever heard of Gehry? He's a very famous architect. He built like the Metropolitan Museum and all kinds of other museums. Very, very famous architect. He has sued just about everybody because they want to change his designs. Know-how. So your initial know-how. You know what is the prime example for know-how? Coca-Cola. Does anybody know what's in there to create the Coca-Cola flavor? It's secret. It's a know-how. They have not published it anywhere. And everybody tries to copy it. I mean, I don't try to copy because I maybe drank 2 Cokes in my whole life. It's too sweet for me, that stuff. But a lot of people like it. And they have just decided on, you know what, we keep it for ourselves. We don't tell anybody. There's a lot of advantages to that, too. One of the advantages is, we'll get to this, but I'll ask you anyway, how long does a patent work? Does anybody know? 20 years, correct. So you file it today, and 20 years from now, it's over. Now, which means 20 years from now, everybody's free to copy it. It's completely legal to copy. Now, let's go into medical field. So now we have this prototype built, right? Emphasized, and then we have basically a design phase, an ideate phase, etc. So we built the prototype. How long does it take from a prototype, if it goes well, to get into a medical product? Guess. Class 2 beat product. We don't want to make it too complicated, but not too easy either. What do you think? 1 year? 2 years? I would tell you an average between 5 and 7 years. So, which means, let's take the worst part of it, 7 years. You have only 13 years left in your patent. So, you hopefully come up with new innovation in the meantime. If you would have not filed a patent, not told anybody, then it's basically eternal. But in the medical field, I can tell you that doesn't work either, because people will copy whatever you have. They buy things, and then they would do something the Chinese used to do. They do reverse engineering. They just buy it, and then they kind of like look at it, and then they copy it, and they don't necessarily completely copy it, but they reverse engineer it. That would be covered by a patent, so that could not happen. Now let's ask another question. Actually, I'll get to this in a sec, but I think it's kind of fitting to that. So I filed a German patent right now. And then somebody in India comes up with an idea half a year later and files it too, but I don't decide to actually make my patent available in India. Can you do it in India? Can you file a patent in India? No, you can't. When I have a priority in Germany, it is in the world. Now I ask a different question. Can you actually build it in India? Yes. Because I have not decided to actually make my patent valid in India. So you can build, you can just say, thank you very much for filing the patent. I'll do it here anyway because you were dumb enough not to file a patent in India. But you cannot file a patent anymore. Patent is done. It doesn't matter where you file it in the world. The one who files it, the first date counts. Now, we'll get to this in 1 second, but I'll quickly say it anyway. The first 18 months of a patent, it's not even published. You don't even know that it exists, this patent. So when you actually look for patents, you may think in India, well, nobody has filed this, I'll file it now. But you'll find out 13 months later when the German patent is then coming on the market, oh shit, it didn't work anymore. So you might as well throw your patent apart. You don't know. Does anybody have an idea why you do these 18 months? Why it's basically secret for 18 months? It's basically to give these people who had the first idea a head start. Because big companies love to copy right away and love to actually file for this one patent 3 other ones in somewhere around, and they say, well, you have 1 patent, I have 3 patents. Good luck. And so that's what very often happens, and that you keep everything secret for 18 months. Okay, let's go on. So a basic requirement for a patent is it needs to be new, inventive, industrial, applicable, not excluded, sufficiently described. So a couple of things to these ones in general. New is clear. Remember the definition of innovation most of you used? Something new, something done new. That's kind of like what you defined as innovation. Not necessarily yet. It comes later on when it says industrially applicable. You can actually be made, manufactured, done. It should be inventive. Inventive means it is a process of not just putting A and B together, but actually coming up with a new inventive character. It's a little difficult to define, and typically you have some stress with the patent offices on defining inventive. Because if you, for example, had a patent, an idea, and you had a patent, and you had a patent, and I use the core contents of what you had and I put it together, I can file another patent. Because I actually was inventive. I used your ideas to actually create something completely new again. And that is inventive, and I could actually use your patents to file another patent. That's okay. Problem is that I have to pay you royalty, and you royalty. I have to pay you money, which I don't like typically. Okay. Now the most important thing is what a lot of scientists love to do is publish papers, right? We want to have a Nature paper or whatever, really good stuff. Lots of impact points. As soon as you have made your invention publicly available, you disclose it, you basically show it, you cannot patent it anymore. Done. So scientists do that very often completely wrong, that they're so eager and excited about telling the world about their new stuff that they forget filing patents. I can tell you that happens significantly more often than not. And what we normally do when I actually look at on whether there's a patent actually valid or not, I actually look at publications and see whether anybody has published it before the date of the patent was. If that's the case, the patent is void, is not valid anymore. So that's what I do typically. That's the bad part when you try to actually get, so you come to me and said like, I have a patent on this one, right? So you should pay me some money. I said, let's wait. Let me check first. Because the patent office doesn't do that, or very often doesn't do that. And then I'll find out that you were so eager when you were doing your PhD that you published a slide paper and you already indicated your invention. And I said, well, I'm really sorry, you published it already. And then later on you decided to patent it. Bad luck for you. Public domain, no patent possible. So whenever there is a patent issue and you have a document which says patent granted, it doesn't mean anything. It just means that the patent office has found nothing against it. But they cannot check everything either. So having a patent does not necessarily always give you the right for everything, but it's a good starting point. But please do not publish anything if you ever decide to file a patent or if you ever believe there's a patent behind it. So what is an invention? It's, for example, improving existing process technologies. That's clear, right? It should be independently conceived, which means you actually came up with that yourself. It should be novel and not obvious to skilled people with a commercial asset, and that can't be protected. So not obvious. What they normally do is when you have an engineering topic, they will have a patent examiner on there who also is an engineer. So it's an equal. And if the engineer says, I'm really sorry, but yeah, that was pretty obvious. Like, I'll give you one quick example because the US actually filed a patent and had to fight very hard. You are quite aware that you can use infrared to transmit data, right? You have a light, you have a LED, and then you have a receiver, and you can transmit digital data. Now, what this company did is they used an infrared transmitter and receiver and went through an RF shielded window. RF shielded window is like you basically try to break the radio waves and eliminate them. It doesn't work with light though. Light goes through. Now, they patented using a transmission system through an RF shielded window. Is that inventive? Well, I believe it's not really, because I'm really sorry. I mean, going through, that's pretty obvious to me. In the US, they got a patent granted for that one. And then we fought for it, and we said, I'm really sorry, but this is actually something that an engineer should come up with. That's pretty obvious. It's already working. It's not they invented a new system for transmission. It's just that they try to get through an RF shielded window which would break radio waves but doesn't break light waves. So I thought that was very obvious, and we fought for 2 years, and we actually got right. And with that, the patent was void, and they could tear it apart. But it was granted already. So, okay. Oh, yeah. So invention can also be done by accident, of course. Right? Can just happen. And most of the things that we do are by accident. I quite honestly admit you that when we go try to find this burning problem, we go to the surgery rooms, and we actually find by accident, oh gosh, there's something completely new that we not thought about it. And that we didn't think about it. It was not a planned process. It was a process where we kind of like fell over it. It was kind of laying in our way. Okay, I think we don't have to go through this. Now there's all kinds of databases around. This is just a German one. You don't want to use that because it's in German, so you wouldn't understand it. But use Google Patents or something like that. Or the US Patent Office database. Very often they use somewhat of a Boolean system where you just combine words, MRI and RF coils and or not blah. So Boolean combination. And you can actually find out who has filed something on this area and whether there is already availability. What did I just say about publication? So how old is the publication that I find on this database? It's not newer than 18 months. because it's not published. Everything you file now will only be published in 18 months, which also means that the information you get is only half correct or a third correct, because you simply don't know what happened the last 18 months. That's a real problem, because now you're kind of excited. Nobody has filed it yet. And then you start filing it. So it's kind of like a dangerous part, and you simply don't know what happens at the end of the day. Okay, so just a little bit details on that one. New means never disclosed. Inventive means not obvious to a person of ordinary skill in the relevant art. Industrial applicable must be able to describe at least one way of performing the invention. So you cannot just come up with a completely hypothetic and visionary approach that is not manufacturable. Like having a rocket flying to the whatever, outer space, without actually describing how you would make it. This would not work. This would not be considered a patent. So, in general, I would really, really advise you, when you do in the medical field, as long as it's not software. Software is another issue. Software is generally not protectable. But what you can do with software is you can actually patent the way, the sequence to get to something, or like a diagram, like a way. I'm actually doing this one, then I do this one, and then I use this information to do this one. This part, this description is patentable. The code itself is not patentable. Also, what's patentable in software is algorithms are patentable. So you can actually use a certain algorithm, you can patent it. Now, the disadvantage of patenting algorithms is you actually show everybody what the algorithm is used, and if you use it just a tiny bit different, it's not patentable anymore. So you basically go around it. So filing a patent also has a disadvantage of you make it publicly known that this is my patent, which also gives others the ability to go around it by just slightly changing things. So what happens is when we file in Germany now. So I filed in Germany on the 1st of January 2019 a patent. Then basically I don't have to do anything for a year. And then after 1 year, I have to decide on whether I actually file for international protection. It's called PCT. It's called Paris Treaty of something. Doesn't really matter what it means. But then I can actually say, I would like to file an international patent later on. Then you have another 18 months after that. So basically, that's the publication with the 18 months. So basically, 12 months plus 18 months is 30 months. And I basically have relatively quietness for 30 months with respect to cost as well. Does anybody have a clue? I think it comes next, what a German patent costs. I'm not sure what an Indian patent costs, but I can tell you what a German patent application costs. So to file for a patent, anybody have an idea? Come on, tell me some numbers. Wake up. Just what the patent filing costs, and whoever prepares the filing is a different story, because you can, in Germany, and I would think it's the same in India, you can file a patent yourself. You don't have to have a patent attorney. A patent attorney is just basically an advisor, a service guy who helps you do it or does it. I have written patents myself completely, and I've actually gotten them granted too. It's not that difficult. When you just look at how other patents are written, you kind of like copy the process. You can do it yourself. So assuming you want to do it yourself, how much does a patent application cost you in Germany? Come on, give me a number. Throw something out. Wake up. 5 euros? 200 euros? Anybody for more? 1,000? It's less than 100. 60 euros. So theoretically, you can do a patent application for 60 euros. And I've done this before. It's not, I can tell you, if you write it yourself, it's probably going to be a shitty patent, but it's not a problem. Now I give you also one additional hint. Not hint. I have for my PhD students, they have a certain requirement of doing papers. Typical, right? So they have to write like 4 first author papers, journal papers with a certain impact factor. They have to write all kinds of conference paper, and they have to write a patent. This is mandatory for my students to write a patent because I want them to understand how patents are written. I want them to actually look at patents and write it themselves. And I pay the 60 euros. Who cares? Because I think it's an important knowledge. And it's actually for you. It's doable. 60 euros. Now, if you involve a patent attorney, that's the one above. If you want involve, that's all the German numbers. No idea what it costs in India. Probably cheaper because the labor is a little cheaper. But the cost of the patent attorney would be about 3,000 euros roughly to write the patent. This one you can save yourself. I guarantee you that your 60 euro patent you write yourself is not a good patent. And the one for 3,000 euro is not necessarily a good patent either. The quality of the patent attorney is really relevant. So you need to take somebody who really is in your field and kind of like knows the field. So, but it's not something which is completely out of the world. So the PCT application, I mentioned this after 12 months, that costs another 3,000 euros. And of this 3,000 euros, you cannot really save anything because these are mainly fees. You have to pay them anyway. And then after 30 months, you have to decide on whether you want to go into nationalization. So I started with a German patent. I still have only a German patent. I only maintained the right to file internationally. And after 30 months, I basically say, now I want to go into the US, into Japan, into India, into China. And you can basically say for every country, it's about 3,000 to 5,000 euros. So it gets really expensive. So what we do, just a strategy that I have, is we file everything German-wise, because then we either do it ourselves for 60 euros or 100 euros, or we maybe employ a patent attorney, pay 1,500, 2,000 euros. I've actually negotiated my patent attorney down because we do a lot of filings. And then we decide after 12 months on whether we go for the PCT. Sometimes we don't. Sometimes we just say, you know what, it was not really such a good idea, let's not continue. And we just maintain the German license. Sometimes you go for PCT, then we have to invest another 2,000, 3,000 euros. And then after 30 months, you have 30 months time now to actually do something, to validate on whether it was really worth it or not. Then we decide on whether we want to go international. And very often we don't. Very often we just say, oh, really was still not that good. And we skip it. But if we wouldn't have done it, we would have no protection. So personally, I believe the strategy should be try to protect it, and then decide later on whether it was really worth it or not. So commercially, because patents, the only reason why you do patents is because you want to secure your commercial future, right? A patent is not saying that you can do something, it just says that other people cannot do something. So basically it allows you a monopoly on a certain aspect. Monopolies are typically not allowed, legally not allowed, except for patents. A patent gives you a monopoly protection for a certain segment. You don't have to do it, but if you have a patent, you can prevent others from doing it. So what my buddies from Siemens always do, they don't do it to protect to basically make sure that their business is, that their technology is protected. They just want to make sure that nobody else comes in. So when you sell a patent to Siemens or GE or Philips, I don't want to hit on Siemens too much, don't do it. Because they will never make any money with it. They will just take it, put it in a drawer, and just say, well, I'll have another one. So by the way, I own this one too. So you are going against this patent. Stop it or I will sue you. But you will never make any money because they will not do a license deal. So patents with Siemens or with the big companies are not good. From an outside perspective. For Siemens, of course, it's good to have that. So you protect the market. We already talked about this. Any market you don't file a patent is not protected. So the Chinese, actually, I have to say the Chinese are not that much of copying anymore. They do a lot of new innovation now themselves. So they used to be copycats, we called them, right? They took everything, reverse engineered it, and did it themselves. Because nobody in Europe actually filed patents in China. And then they did it themselves, and everybody was pissed in the world. Then the Chinese are actually getting much more innovative and do their own patents. And we, as foreigners, actually file now Chinese patents, because the Chinese got in big trouble that they did not, they made filing patents in their own country very difficult. Now they open up, they had to do it. But what happened is that all the products in Europe or in the US that were manufactured in China, we could not do anything about it. It was just the way it was. But when you actually go, anybody heard of Medica, the show? Medica is the largest, by far the largest medical conference and exhibition. And it's in Düsseldorf in Germany. It's every November. And it's probably the size of, I don't know, 20 soccer fields at least. It's really big. It has like 16, 18 halls, and there's a hall for everything. One hall for diagnostic equipment, one hall for this, and one hall for that. And then there's also country organizations, and Chinese companies were very much present. There's 500,000 people coming there for this show. Then the Chinese were actually stopped in the German customs because they wanted to show things in Germany of products they did in China that offended German patents. As long as they were not in Germany, it was not a problem. They entered Germany, it was a problem, because now they infringed the patents. And they were kicked back. They were thrown out and sent back. So patents are quite powerful, but they're also quite expensive. So you need to be a little careful. But I can tell you clearly, if you have it says here, can be used for bargaining purpose. That's a very important one. Just a quick example of my life as well. We had a problem with a company from Spain who sent us basically a letter saying that we cannot sell one of our products anymore because it was infringing one of their patents. And in all honesty, it was true. But we luckily had 2 or 3 patents in our portfolio that they were infringing. So we just used for bargaining. We just said, oh, yeah, you're right, but you have forgotten that you infringe our patents, by the way. And they said, let's do following deal. We forget about it. And that worked well. So, and that's what actually these companies do. I was involved, now going back to Siemens, I was involved in the late 90s in a bargaining deal with all the big manufacturing companies. And there was GE, Toshiba, Siemens, Philips, Hitachi, and I think that was it, sitting there. And they basically said, we're not going to go into the details of our patents. So Siemens said, I have that many patents. And GE said, I have that many patents. And they had that many patents, and so on. They basically said, you know what, we cannot really figure out who owns which technology. Let's do following. Let's just basically make a transfer of payment based on the quantity. And we don't even look at the patents anymore. That's how they agreed. That's why everybody in these big companies uses the technologies of the other company. They'd call it differently, but it's still the same thing. And they don't pay anything typically. They basically agree that we share the technology and we just don't allow anybody else to come in. What is this called economically? It's called an oligopoly. Ever heard of that word? Monopoly, one. Oligopoly is several, but very limited. It's like a club. And it's the club of the diagnostic imaging manufacturers. And that's why you probably will not see a small manufacturing company or a new manufacturing coming out, because they cannot fight these 4 or 5 people out there because they're so strong and they basically control the market and the technology. Oligopoly is not illegal, by the way. Okay, so very important for bargaining too. Now, when you do a startup company, different thing again. When you do a startup company, you have to give the investors something, right? You have to give the investors technology. That's what they want to see. They want to see a market. They want to see this burning problem. They want to see the painkiller. They want to see the technology for that. And they want to see that it's somewhat protected. So you're starting a company now, right? CEO. I'm here. Give me $500,000, euros. I start the company. And then they say, do you have patents? And if you say you have no patents, what will happen? not always. I'm saying with software companies that's not the case, but if you do something with hardware, you need to have a patent. Then I'll give you the money if you have a patent. Because if you're run over by a car, or I don't need you anymore, I still have the patent as an investor. If the same thing happens without a patent, I have nothing. Because an investor cannot really do the whole thing. He needs to have something as a protection. So if you really want to do a startup company, and it's not a 150% software product, I would advise you to think about some form of protection, and maybe some form of IP, and maybe even patent. Okay, so these are the two things. And I think that was it as a summary. So you can do all kinds of things, and trademarks you should consider too. I protected the names of my companies typically. You know what really is stupid if you have a company and you start and you have forgotten to secure the internet domain? Happens all the time, by the way. So secure your internet domain. That's also IP. The name of the internet domain. Very important. I give you a funny example on this one. I did this myself, actually. The German government in 2006 came up with a new strategy. And they called it the high-tech initiative. High minus tech minus initiative. And they made everywhere, this is our high-tech initiative, high-tech initiative, high-tech initiative. And you know what I did? I went into and reserved the internet domain for hightechinitiative.de. I just thought, fine, I'll come up with that too. And I just stole it, basically, just for the fun of it, actually. And a month later, the German government called me and said that they would like to, actually, the funny thing was it was not the government who called me, it was a marketing agency who called me. And the marketing agency said, we would like to have this high-tech initiative domain. I said, yeah, what for? Yeah, we're working for a client. And I said, who is the client? And I said, well, we can't tell you the client. I said, well, if you can't tell the client, then I can't give you the internet domain. And 3 months later, somebody from the ministry called me and said, I mean, they probably have a right to that, but we would not want to sue you, so can we get an arrangement for this domain? I gave it to them, actually. And I don't think I charged anything. I think I just gave it to them for the fun of it. But I thought it was a really nice, cool example of how stupid governments are, too. And how stupid big companies are. They come up with these buzzwords, and they have a strategy. The whole government strategy was put on this, and then they have not even bothers to reserve the domain. I think that's a big flaw. I would have thrown that marketing agency out right there based on this one. It's not the government. The marketing agencies came up with that and they forgot to reserve the domain. So please think about that too. Yeah, very important one. That's actually the one I was already one too fast. Think carefully about legal issues. Now, if we, for example, sit here together, we may not, maybe if you forget right away after I said it, you forget about this. You sit here and we actually come up with this cool new product. Now, it originally came from him, right? He was the original idea. And now, you all helped him to do this. Who's the inventor? All of you. Now, he probably has a 70% share or an 80% because he started it, but every one of you has a participation. Now, as an inventor, you don't like that because it's actually my idea, right? Please do not forget that every little idea is important too, and people who were involved in creating this invention, they should be mentioned inventors. And if you don't do that, maybe, I mean, for a lot of things, you probably will nobody will ever find out. But if you go to the US is very picky on this one. If you go to the US and you can actually show with the pictures that we were taken here at this class. I was at this class. I made a selfie. Look, that's just the invention on there. And you can prove that you were an inventor and you were not put on as an inventor. The whole patent is thrown away. It's not as if it would never have been there. So be careful about this. I typically put in more inventors than necessary. I just put everybody on. I don't really care. And then I make an agreement with them that they basically release the patent rights to me for €5 or something like that. You know, at the end of the day. But please be sure that you put that on. Okay. Are we close to coffee? 5 more minutes? I don't know if I can talk. Oh, yeah, I can talk about 5 more minutes. All right, another idea. That's an idea of one of my PhD students who is actually a nuclear engineer. Nuclear engineer doesn't mean nuclear power plants or bombs. It's nuclear medical. So using like the fluor-18 components or these radioactive components to treat cancer. And a very funny little side story in this one is he's from Iran. And he tried to get a visa in Germany and put down on the visa application that he's a nuclear engineer. Not a good thing. I don't know how many letters I had to write to the German government to let him in, because they did not understand that there was nuclear engineering also for medical applications. They thought he was building bombs here. Basically, get the technology to build bombs from Iran, right? And so that was a really bad thing. Anyway, so what we did now is, and you can't really see it very well, is let's go, like we did before, let's go for the burning problem first. The burning problem is when you have cancer, melanomas, skin cancers on your arm. What are you doing with it? You cut it out. Cut it out. Now, when you have the same skin cancer, which happens very often, close to the eye, on the nose, or somewhere in the face, we'll cut it out too, right? No, you want to cut it out. It's my face, right? Who cares about my arm? But my face, don't touch my face. So it's a very critical area. So the burning problem was that people just were very reluctant to get their face touched. But you still need to do therapy on it. So what we thought of is how can we solve this problem without surgery? And you can do actually superficial radioactive treatment. And what we now did is we actually created, and you see that a little bit on the bottom, we created basically a surface map of the face, have that combined with the MRI scan of that lesion, so we know how deep it goes. And then we 3D print a personalized patch. You can kind of like wear it as a bandage. And it's very personalized. We know exactly what the diameter of your tumor is. We know exactly how deep it is. And then we just have a 3D printer. Well, it's not that simple, actually, because you need to have biocompatible material. You need to be able to integrate these radionuclides into the printing material. And you need to actually print it with the right dose at the right area. So it's not that simple. But you got the burning problem again? The burning problem, people don't want to be they don't want their face to be operated on. But you still want to provide a therapy option for them. And this is now a therapy option that solves a lot of pains and gains for the patient and also for the therapist, for that matter. So we actually have, this is still a fake it kind of approach. So we have not completely done it yet. But we just published a paper of how we actually combine we use yttrium-90 and rhenium as the radionuclides, and we combine this with a microgel, a hydrogel, and this can then be printed, and we can then print the forms for the patient. Okay, so the paper has been published, has been accepted, and now we're actually building the product. The printer is already finished, and now we're trying to work it out. So we also have some industry partners already on that one, so it could be an exciting little project. Okay? That was it. And I would start with this one after coffee break. Coffee break. Here we go. Bravo! This just comes at the right time. Okay? So please have a coffee or tea or whatever you want to drink, and then come in and rearrange your boards. Yeah, make them so all the information for your project is available, visible, and is maybe on eye height, right? Not like this or like this. So try to make it as nicely as possible. At the same time, try to read over it and get rid of the stuff you don't need anymore. So limit to the things that are related to your project, okay? So we'll meet again, or we start again at 45, but please have your thing arranged already at that time, okay? Can you quickly pay some attention to Professor Abhishek saying something about the dinner tomorrow?
Okay, so tomorrow there is dinner arranged for all of you guys, and we want you to participate. So it's in the college MPH itself, and so first day, if you remember, in the morning when professor was not here, we did little bit of brain, ice breaking sessions. So in that, I found that there are a couple of dancers and there are a couple of singers. So it's very informal thing. So let's know a little bit about your dancing skills and your singing skills, apart from your skills, what you're showing it to him here. So I remember those names, by the way. So I know Chandana and I know someone else. Okay, I'll figure it out. But please, you need not wear any fancy costumes or anything. Maybe couple of performances and then couple of singings in MPH. And then after that, we'll have early dinner. Early in the sense, for us, it's very early, but for him, it's right time. So around 7 o'clock is what we're planning to start. So here we'll be done by 5:30. So you have around 1 hour. So 6:30 we'll assemble there, have this kind of fun for around half an hour to 1 hour, and then we'll follow the dinner. So all of you, please join and make it a memorable day for him as well as for us. Thank you.
Okay, still works, right? Yeah. So whoever gave me advice about, is it still working? Yeah, it is. Do you hear? Yeah, okay. So I was at the beer club yesterday. That was pretty good. So today I'll probably go somewhere else, Bangalore Brew Works. So we'll see. I'll give some. If anybody's interested, I can give you some ratings on this ones. So the Brow Works, I think in South they were not so good. Yesterday the beer club was okay. So we'll see. I'll see what else comes, what else good comes. Okay. So what we do now is we're not in the search modus anymore. We have identified a burning problem, I hope. And I hope we also have some initial ideas, but please do not focus on this initial idea too much. It basically is just a reference. I want you later on, or part of this one now, to start actually thinking about potential solutions. And we use something called design sprint. And design sprint originates originally from the guy who came up with that is a guy called Jake Knapp, very nice guy. I met him in London not too long ago. And what he was, before he actually started his own little consulting company, he was responsible at Google Ventures for basically evaluating new ideas within Google Ventures. And he came up with a process of actually checking out new ideas or coming up with new ideas in a fairly orderly process. And it's a 5-day process typically. Let me just go on one time. It's typically a 5-day process that allows you to actually answer very important business questions by designing prototypes and testing prototypes. And the class, typically after these 5 days, comes up with a real working prototype. A software prototype or hardware prototype is mainly, they used it initially for software, but you can use it for anything. And it's really something you can go out and test. So the concept basically is a little bit like this. You, instead of having this idea and learn, you actually do a little bit of a sidetrack and try to actually build and launch something at the same time. So it's that 5-day process which starts with a mapping the problem, mapping the maybe the general concept. So whoever is the proposer of your project is basically the one who maps it. Basically the one who kind of like shows what they were talking. You guys are just simply listening later on and try to actually understand what he or she is saying and trying to understand and come up with the story behind it. On day 2, you actually sketch a lot of potential solutions. That's what we will do a little bit here. We will sketch some solutions. And on Wednesdays, it's like you create actually a storyboard and you decide what you will continue to build. So you have some options and you build something. And then you will build a prototype, and that prototype, I mentioned it, I think, yesterday. You can use like Marvel or some other apps where you can create a actual working app within very few hours. Or you can create a movie in like 1 or 2 hours where you have something that you can show a customer. You can fake things. So there's this one word, I think it comes later on. If you can't build it, fake it. Just make something up. And no, it's not actually that early, but about 10, 12 years ago, I was trying to come up with a new idea and with a new business concept. And what we did is actually we reserved an internet domain. And we placed all kinds of things on the internet domain, what we have. And that was all fake. We didn't have anything. We kind of like just said that we would have it. And we wanted to see whether people are interested in it. So we tried to actually, by putting up a fake website and putting up a fake product, trying to get a response from people from the outside on whether they would be interested in buying it. Because we had not a really idea who was a customer. So we were spending some marketing money on Google to actually promote our website and just saw what came back. And it was very interesting. It actually led us to believe that we shouldn't do it. So we scratched it again. But it was a fairly inexpensive way of finding things out. So this is the test part. We will not do that here. So you will not test. I just want to basically give you a little snitch, a little sniff on what this design sprint could be and how powerful that could be. So we will do a little bit of the mapping. We'll do a little bit of the sketching and a little bit of the prototype. Now prototyping actually you'll probably do tomorrow, and a little bit of the creating a story. So having said that, so this is what we do. This is more details on it. So I actually don't look at that too carefully, but what it says on the black one is what people normally do and what the sprint does. And so there's quite a bit of differences. You work together normally in this what we call brainstorm meetings. That's what, ever heard of brainstorms? Brainstorm is almost a no-go word anymore. You should not do brainstorming anymore, because brainstorming means I force you guys, you have to come with me now. We'll sit in this meeting room and we think about this damn problem. And nobody leaves this room before we have a solution. Now, is that stimulating? It's kind of like, damn, I have to do it. And it's not, you're not in a play modus. It's kind of like forced to do something. And that usually does not come up with good ideas. The other thing is that you're typically in an environment when you brainstorm where people are together who know each other. People are together who know the problem already anyway. They have not found a problem yet, so why would they find a problem if you make them sit together? So think about this. When you have the same kind of people working on the same kind of problem, and you can't find a problem, forcing them to sit together and coming up with an idea is not going to help either. So the idea that we have here, like somewhat heterogeneous groups, a little bit different inputs, that could be much better to a solution. And you need to give people time to do individual work. Because you may have realized that already, that in your group, I know you can nod or not, you can say that there's probably one who determines where you go, and maybe one or two who actually lead the others and say what they should do and try to influence the others. I'm not saying that's bad, but that's what happens typically in groups. So when you not allow people to have an individual time and individual input, they're typically not heard. They cannot contribute the same way because they simply are overruled, or they want to start saying something and then somebody else jumps in and they can't say it. So this is an important part on this design sprints, that you combine quiet individual work with teamwork. And I believe that's a very powerful tool, because otherwise you would only always listen to the same people and it would always be done the same way. Maybe you remember the time when you did this first drawing that we did, the surgery room of 2029. Do you remember that one? Think back how you got started. Typically, there's one person who says what we should do. And then you start drawing. This is what very often happens. But then you go along with what that person said, rather than actually coming up and putting your own idea in. Is that what happened? Don't see anybody reacting. Probably nobody wants to admit it, right? But that's typically what happens. And I would be very surprised if it doesn't happen here, if it didn't happen here. It's nothing with India. It's the world works that way. Okay, so then on Thursday, that's what I would like is that we, in a sprint, we fake things. So rather than building a physical prototype, which takes some time, we just make something up and try to use that as a convincing part. I'll show you some examples later on. This is what we not do. What you would normally do then, when you actually have done this fake product or a real product, you would go out and test and then get feedback and see what can be improved. So I want to show you, can you do me a favor and click on the link up there? I'll do that. I hope we get started. Oh, let me go back. Let's do something different. So why can I not do this? So let's just use this and copy it. There's no audio? No, I don't think there's an audio needed. Oh, but it doesn't show. We'll restart again. Now, you remember it was a 5-day process? Now, we show you this 5-day process now in 3 minutes. And you see also, let's start again from the beginning. You see also very well here how the sticky notes are used. This is the most powerful tool they actually have. Entire sprint process in 5 days in 3. So we're talking day 1, expert interview. So the guy or whoever presented will say what we're doing. Then we already said something about it. How might we do things, right? Notes are put up. They are arranged, categorized. Some of this we'll do today. Then there's a voting. They do a dot voting. They put a sticker on there. And these will then be followed up. We will put a long-term goal on. And, excuse me, that's why we need a decider now too, who really makes a decision. Then we raise questions that we want to follow up on. We create a story map. We will not do all of this, but this is what typically happens in this day. It's a very full day. Now what we do, lighting presentations we will not do. That's something where you just look for information from websites that could help you, some inputs you get from outside. This one we may do that, some sketching. And it's always the timing is important. You need to be really quick on this one. That one we will do. Then we put this all up, and then we make another dot voting again, and then create somewhat of a user story later on. But you see the walls they have? They have a complete white wall. That's it. That one we probably will not do. See what they do now, everybody puts a test flow up and then they decide which one is the best one, and then they always use the team approach to put it together. And this is now the story. And then you start prototyping. This is maybe what you want to do tomorrow. You have to decide for yourself how you do this. And then you create the fake prototype. But you need to first understand what is the test questions that you ask? What do you want to find out? Because you can give it to them, but if you don't really ask the right questions, it's also difficult. And they do high fives, as you see. Okay, so that was the quick 3-minute of 5 days. And we will do something different. We will do this 5 days in 2 hours. Okay, so we'll do a little more. I have handpicked some of the things that I believe would be fitting, and I hope they work. But if you are interested in knowing more about this design sprint approach, there's a book. It's called Design Sprint by Jay Knapp. It's a very, very popular book. It's Amazon. It's like $15 or something. It's fairly cheap. So that's available as well. Okay? So what's this? Has anybody seen it already? What do we do there? Get up, shake a little. It was a bad timing. I sometimes don't know when the coffee breaks out. You were walking around, so it was not like that tired. But for me, it's actually good. So what do you see here? Yeah, maybe. An elephant, or what do you see? I mean, I know what it is, so for me it's very obvious, but. Someone very what? Oh, headphones. Okay, and what is the other stuff then? It's the baseball cap, right? Yeah. That was almost too easy for you guys, right? Yeah. Typical look when you go into a software development and you see all the geeks sitting in front of computers. They all have headphones on and maybe a baseball. Maybe the baseball got the other way around, right? But that's just typical. I give you one funny story. It doesn't count, it doesn't go for this club here because you are heavily female dominated. But one of the companies that I'm invested in, they were heavily male dominated, and heavily means 100%. So there was like 5 software engineers sitting always like this and staring at their screen and doing some program. Nobody knows what they exactly were doing. And then the daughter of my wife's best girlfriend, she needed to have an internship, and I said, she can go there. I'll organize this. She was a very pretty girl, and she came to this group of 5 boys who were never looking away from the screen, and it was actually smelly when you get in this room because they were probably drinking in the evening. Who cares about showers, right? So you can shower every week, that's good enough, right, like this. And their attitude changed completely when this girl showed up. All changed everything. So one more, it's also a good indication, please have that in mind too. When you are looking for a team, try to find a team that is as heterogeneous as possible. So don't not 5 25-year-old girls who do the same thing. Try to actually make it as heterogeneous as possible, because you also will find out that different age groups, different sexes, different backgrounds contribute different input to your topic. Typically, you are all having the same background, pretty much. You will have the same informations coming for it. It's not as good as if you have a heterogeneous group. So think about when you want to ever do that and set up a team and try to come up with innovation, do it as heterogeneous as possible. It really, really helps. Put people in there who know the domain, people in who have no idea, and so on. And not only young people, put some older people in there, or the other way around, right? It really, really helps. It's another funny story. I'm renting my students out. I sell my students like slaves, right? I sell them. And I sell them every once in a while when big companies want to do innovation groups. Siemens, let's go to Siemens again, right? Siemens they are working, typically a Siemens engineer starts working with Siemens and he dies at Siemens. They never leave that company. So what happens is that these people know only Siemens. For them, nothing exists outside. And all the people in Siemens, they think kind of like the same way. They're Siemensianer, they call them, right? They have this, that goes for all big companies, by the way. They are very attached, right? People love this. And they need external input because they're so stuck in their own little world that they don't even see the outside world with other eyes anymore. They only see it with their eyes. And they believe that everything that comes from Siemens or GE or Philips is the best it's ever done. And whatever we do is the best. And whatever we say, they probably need outside. Well, that's not true. They find that out too. And that's what the managers know too. So they need outside input and they need innovative input. And I have actually a couple of friends at Siemens. And I said, why don't you take 3 or 4 of my students every once in a while for these things? So they pay us a little money and then we send the students over there. And they're part of these teams. It's pretty cool. So think about, this is not a business model for you, maybe. But sometimes it's very important to have these kind of inputs. All right? You want to sit down again? I mean, you didn't have to stand anyway, but I guess you wanted to. Okay, so the first thing that we do for our project is that we think in quietness, please. So everybody individual in quietness thinks about a super optimistic goal for your device, project, whatever you want to do. What do you want to reach in 12 to 18 months? And I would put 1 goal per post on it. Don't put too many words on it. Be relatively precise and maximum 5 minutes. And you put it on a certain area and you know what happens afterwards? We'll dot vote on it again, right? So everyone, do not peek over to what your neighbor does. Do it for yourself. What is your long-term goal? With what do you want to reach? And it does not have to be, even though it says here, it doesn't have to do anything with revenue. It can be something completely different. Think about what is important to you, what you want to reach in the next 12 to 18 months, okay? And let's be really, timing is really critical, because if you think too much, you will never get to an end. So please write as many, no, actually everybody only 1 long-term goal. Okay? Starting now, 5 minutes.